Greetings, math wizards. Talk about inequalities today. We started about a little bit last week. Let's apply that to what we know about equations. See some math. All right, first of all, let's remember, if I'm going to graph these guys here, p less than or equal to -3, we start by noticing that the alligator eats the larger value, which in this case is -3. So I'm going to put -3 on the number line there and circle it. And because it is an equal to, I'm also going to fill it in. And the alligator's eating the -3. So the -3 is the larger value. Therefore, the p is less than that. Which tells me all the values on the number line that are less than any number have to go left. And really, the number itself, the -3, doesn't even matter here. We just know that the p is everything less than the value given. That always means arrow left. Less than, in this case, is going to tell us the arrow goes left. And the other one, 7 less than x, we're going to start with 7 on the number line. And because there's no equal to sign, we're going to leave that open circle just as it is. Now we're going to read it as 7 is less than x, or we can look at the x and remember the alligator, and it's eating the x, which means the x is greater. So we can also say x greater than 7, or the 7 is less than x. Either way, we want to be able to notice x is going to be values greater than 7, and that always goes to the right on the number line. Notice the inequality is not going to point the direction you need to go all the time. That only works if the variable's on the left. Okay, so that's a basic review on graphing. Let's use that today. All right, let's compare here. X is greater than 4. We already know how to do that. We just did all values greater than 4 going this way. Now, let's see what we can do to an inequality. Let's start with x greater than 4. Just like an equation, we can do something to both sides. And as long as we do the same thing to both sides, that's going to keep the equation balanced. So in this case, we can multiply both sides of that equation by 2. And we can get 2x is greater than 8. And we'll see that even if I graph that again, and I'm going to stick with my original solution of 4. Okay, everything above 4 is the solution. We're going to find that it still makes the equation true. If I pick some values for x that are anything greater than 4, I can pick 5 or 6 or 10, whatever I need. Without that. Then we can plug some of those in and see. If we plug in 5, 2 times 5 is 10. Is 10 greater than 8? Yes, it is. How about 6? If we plug in 6 for the x, 2 times 6 is 12. Is 12 greater than 8? Yes, it is. So we can see that this is true. If I multiply both sides of the equation by some value, the equation stays true. Anything I plug in will still work. It's still balanced. It does just what it's supposed to. Let's look at something else that might happen. Again, we've got 4, x is greater than 4. It's the same we just did. We're just going to do a different example. What if now we take x greater than 4 and we multiply it by -2, which is perfectly legal. As long as you do the same thing to both sides, it's always perfectly legal. Let's see what happens now. Let's just throw in a few numbers and check some solutions and see if it still works. Okay. Let me graph this guy real quick. So this is still, our original equation was x greater than 4. So what we want to know is it still true with some of the original solution values, everything on this arrow? So again, 5 or 6 or 10, anything greater than 4 should make the original equation true. Let's try a few. 5 for x, let's plug that in. -2 times 5 negative 10. Is negative 10 greater than negative 8? Think about that. We'll even scroll up here, and if we want, we can help you guys by throwing it on a number line. If I put negative 8 here, negative 10 is farther out on the negative side of the number line. Is negative 10 greater than? This is the greater than area of negative 8. No, it's not. That was weird. It didn't work. Our solution didn't work. Let's try another one. Maybe I just did the math wrong. Let's try the 6. Let's do the 6 here for the x. Negative 2 times 6. We'll do a second example. Negative 2 times 6, negative 12, greater than negative 8. Let's see if that one works. So there's our negative 8 again. Wait a second. Negative 12 is getting even farther negative. It's certainly not greater than, which is going to the right. So that one didn't work. And I bet you know what'll happen if we do negative 10. If we plugged in the negative 10 times negative 2, we're going to get negative 20, which is way out here, even farther negative. So we had a breakdown here. The rule that you can always do the same thing to both sides and keep your equation balanced and everything is still valid, it didn't work this time. This right side, it didn't work. Okay, let's talk about that real quick. To make all of these new solutions, to make those true, we would have to rewrite the inequality. Instead of x greater than, what did we have? X greater than 4. It's actually reversed when we multiplied. Now we have negative 10 is less than negative 8. It used to face the other way. And we have negative 12 is less than 8. And we have negative 20 is less than 8. It used to be the X was eaten by the alligator. It was eating the left side. Now it flipped. It's facing the other direction, and that makes the inequalities true. To this page here, this is the example that we just saw right here, where it all went kind of wonky for a minute because we saw as soon as we multiplied both this page, right here is where everything went wonky when we multiplied both sides by that negative 2. That's what flipped the inequality, and it only stayed true if we reversed. What did we learn? We learned that we can multiply, and it's also true with division. What we just learned is going to be exactly the same with division. You can multiply or divide with a positive number. Nothing changes on an inequality. But if we multiply, and it's true with divide, a negative inequality flips. And what am I talking about with this idea of flipping? If we go back and so how would we apply that? Let's look to this previous direction. I actually misplaced it. There it is. All right. So now, without doing any work, just look at these four for a sec. We're not going to solve them. Can you identify which problems will require flipping the sign? And remember, what's going to cause that is any time the solving process requires you to multiply or divide with a negative as you're solving. So just take a look at those. It's very simple to see where this rule applies, and then you end up solving all your inequalities just as easily as equations. So look at them real quick. Where are you going to need to flip? Okay, let's go over it and see if you're in the ballpark, if you're getting the idea here. Number 1, we have 5m minus 3 less than or equal to negative 4. What we're looking at is right here. I'm eventually, after I add the 3 over, I'm not going to solve these, but remember, I'm going to start by adding a 3 to both sides, and that's going to cancel. And then eventually I'm going to have to divide off the 5 to get that m by itself. Well, that 5 is positive, so there won't be a multiply or divide at all anywhere in the problem, so there's not going to be a flip. It's going to stay exactly like it looks at the end of the problem. It'll still be a less than equal. Number 2, hopefully you're already tracking with me. I'm looking right here, and I see that as I solve, I'm gonna add the 4 to cancel it, and then eventually I'm gonna divide off that negative 6 to get p by itself. And when I do that, let's pretend we already added the 4. When I divide off that negative 6 on both sides, this is gonna cause a flip. So I'm going to end up with p, and the alligator isn't going to be eating p. Right now it's aiming to the right toward p. It's going to have to flip and go towards the answer. And then I just write flip somewhere in here. And so this one, we are going to have to flip because negative 6p. Okay, number 3, look at that one. And again, we see the same thing right here. I'm eventually going to divide that negative 2 off of n. After we add the plus 6 to cancel it, we're eventually going to be here, and we're going to end up dividing that negative 2 on both sides. And because we do that, this is going to require a flip. And so n, right now it says greater than equal. It's going to flip, and it's going to have to go the other direction for whatever the answer is for n. It's going to look like that when we're done. And kids sometimes have a question about these equal to's. Whatever they give you to start the problem, you just stay with that. You never have to figure out whether or not you need an equal to or don't. Either a problem starts with it or a problem doesn't. You have no control. You don't need to do anything about that. All you watch for is whether or not the sign flips. All right, number 4, are we going to flip that one? And hopefully you're saying nope, because at this point it's really obvious. The 11 is what I'm going to eventually divide off, and I'm going to divide by a positive 11. Nothing negative there, no flip. So the inequality is facing away from y. It's eating the other side, and we're going to leave it that way, so there's not going to be a flip. Okay? So to put that mathematically and very specifically, the coefficient of the variable if it's negative, you flip. You'll have to flip that sign. Okay, so that's what we're looking for. Whatever's with the variable, the coefficient, the value with it, if that's a negative value, you're going to have to multiply or divide it off, and that's going to flip the inequality. By the way, x over negative 3, I just realized I didn't give you one of those examples, and I should have. In this case, that's going to have to be multiplied to be canceled on both sides. And whenever you get to that point, that means you're going to flip your sign because you had to multiply or divide both sides by that negative, okay? That's the same situation. Let's solve an equation. Notice on the left first, we're just solving an equation. That's what you guys have been doing for a couple of weeks now. It should be like you could do that in your sleep. On the right side, we have an inequality, and we'll see how they're the same or how they're different. All right, so I'm going to do what I always do. I'm going to minus off the 4, which cancels on the one side, and then you just combine those on the other. Bad guy, negative 12, and then just the equation. If you're solving an inequality, it's the exact same thing, okay? You're also allowed to add or subtract off both sides of the inequality, and it's not going to do anything to your equation to change it. Negative 8 and negative 4 is negative 12. Bring down the negative 3p, and we leave the inequality just like we got it. Notice the inequality started as a less than or equal to. Everything on the left was less than or equal to. It still is. Nothing changed. So far, this is exactly like solving equations. You guys are good to go. Let's jump to step 2. I've got a p that's multiplying with -3, so I'm going to divide. I'm going to divide off both the 3, and it's negative on both sides. Do it on both sides to keep the equation balanced, and I get for p, after I cancel negatives, I get p equals 4. Let's look at the right-hand side. I'm going to do the exact same thing. -3p is multiplying, so the 3 is going to divide, the negatives are going to cancel, and I'm going to do the same thing on the other side to keep my equation balanced. So p is by itself, my pair of negatives cancels, I end up with 4, but this is where something unique happens, okay? And that is that right here, we multiplied or divided with a negative number on both sides, okay? This is, if we go back, so to find this equation still true, we have to go from the less than symbol to the greater than symbol. And I actually literally have you guys write the word flip when you start learning this, so you remember that because we multiplied or divided both sides with a negative number, we have to flip the inequality, and now it becomes p is greater than, even though at the beginning p was less than. And if we plug a value in for that, we will find it's true. Say we do p, any number p is greater than 4, so any number greater than 4 will be part of p's solution set. So how about p equals 10? That's a number greater than 4. If we go back up to the top and we plug that in for p, plug in 10 times -3, we get -30. And we add 4 to it, we get -26. So then we ask ourselves, and we're kind of running out of room, I'll go to the bottom here, -26, is that less than or equal to the original -8? Is -26 a smaller or less number than -8? It is. That works, so this value is true, it's part of the solution set. And that only happened because we flipped the inequality. It maintained the balance and the truth of our equation. All right? So, looking for something. All right, that's it. Sorry guys, I could literally give you a large multi-step variables on both sides distributing inequality right now, and you guys could solve it because it's exactly the same as an equation except for that one piece. All right, why don't you try these two? Pause it, solve them, graph your solution down here, and then I'll do them behind you. Go. All right, let's dive in and look. First, did you guys pick the right one to flip? I'm going to look right here to start, and I see a +4 on m, so I know I'm not going to need to flip. I know the solution down here at the bottom, when I finally get to m, it's still going to have the alligator facing m because there was no flip. If I look at the other problem, right here there's a negative on that coefficient of x, so I know a flip is going to happen. So down at the bottom, I know the alligator's going to switch, and it's going to flip toward s by the time I'm done. So it's that simple. I've already identified whether or not it needs to flip. Now all the rest of it is solving, just like you always do. I'm going to speed solve because frankly, you guys have seen this a million times. Keep the sign the same. No reason to flip it yet, and actually at all on this problem. M is greater than, in this case, if I'm reading it backwards. -12/4, -3. So we can say that m is greater than the -3 because the alligator's facing m, or you can say -3 is less than m. Either way, -3 goes on the number line. And then m is everything greater than. Okay, alligator is eating m, so all the values above -3 are that way. Those are the solutions for m. All right, number 2. I'm just going to add over the 2 to both sides. Now, to be clear, sometimes kids get unclear. There was no flipping going on yet. Adding and subtracting never causes a flip. I'm keeping it exactly the same as it was to begin with. Okay? It's only when I get to this point right here, that green pen right here, I just performed a division on both sides that used a negative, and my flip, it's already written. It's already right there. I just flipped it. That's exactly what I need to do. As soon as I see that, my negative 4's cancel. S is left by itself. Those two negatives cancel, and I've got 6/4. Oops, I'm about to write something else. Okay, and when you graph it, it doesn't matter if it's a fraction. You're literally putting 6/4 on the number line, and S is everything greater. Greater is everything above, which is always to the right. All right, there you go. You're solving 2 steps and you're graphing your solutions. All right, go do your homework. Go practice.